Standards identified in these activities have been adopted from the content standards of the national organization for each discipline. More information on this can be found in the Technology as Facilitator of Quality Education model. The students must calibrate the instruments they will use to test the water quality in the Green Hills stream. But first, the teacher reviews the importance of calibration as part of the scientific process. She implements Science Standards A1 and A2 for grades 5 through 8, which deal with developing the student's ability to perform scientific inquiry and to understand scientific inquiry.
We have to standardize equipment all the time. So when scientists pick up equipment, they don't just, plug it in and start working with it. When you get a computer, you have to set it up, right? Same thing with these instruments. These instruments have to be told what it is you want to measure. And there's a way to get that to happen.
She extends her implementation of these standards by having the students calibrate their pH probes using Apple eMates to test solutions with a known pH.
And now press add. Okay? All right. Now, what will you do to that before you place it into something else?
Put it in the buffer.
Well, you're going to rinse that out. Yes?
This is all that we're supposed to have. You don't have to do this is all that we have to do.
Exactly. Okay, now you wait. Don't shut out of that until you get the other pH reading.
To complete the calibration activity, the teacher guides the students through the process of securing their calibration calculations into their eMates.
Let's review for a second. I go into eProbe, all right, and how is the program going to know that I've got a pH probe? What are we going to do? Okay, Lauren? Okay, go to pH where? In the program, there's a prompt, a setup. Okay, right? It opens up to a screen, and that screen could be pH already, or it could be temperature, or it could be conductivity, right? So I have to press setup. Select probe. Then what do we do?
You select the calibration.
Then I select the calibration. Excellent. And what calibration are we going to select?
pH.
Just pH? May pH. You took pictures, and now what you want to do is you want to look at them, and you want to see if you could make predictions of any of these tests of what the quality might be, okay, when we go out to test them with our equipment.
The students use digital photographs of the Green Hills stream to observe some of its physical and environmental features. They make predictions about the stream's water quality based on their observations, and they carry out experiments to test their hypotheses. They then use the data they collect to construct models that explain how seasonal change affects water quality. This integrates Science Standard G2 for grades 5 through 8, which deals with formulating and testing explanations of nature using observations, experiments, and theoretical and mathematical models. It also incorporates Science Standard F4 for grades 9 through 12, which addresses environmental quality. As the students test the pH, temperature, conductivity, dissolved oxygen, and turbidity of the Green Hills stream, they must consider the various human and environmental factors that influence water quality. This incorporates Science Standard F2 for grades 5 through 8, which requires that students view science in terms of population, resources, and environments. Using Model Builder software developed by the University of Michigan, the students construct a model that displays their understanding of how seasonal change influences water quality. The model uses the data that students have collected to demonstrate how seasonal change can impact the different elements of water quality the students are studying. The activity addresses Science Standard G2 for grades 5 through 8, which involves using theoretical and mathematical models, observations, and experiments to test explanations of nature.
All right, explain your model. First of all, from which way did you attack it?
We used conductivity.
All right.
That was our test, and we had the seasons, how long they were, affect everything in the water quality. Because if the summer's longer, people are going to fertilize their lawn for longer. But if the winter's longer, there's going to be more road salt getting into the stream.
Okay.
Also, we have road quality, like the drainage systems by them. That would affect that. So if road quality was higher, even though it was a long winter, the water quality would still stay basically the same.
Stay basically the same. Okay, what can you tell me?
I don't know.
Can you add anything else?
That's pretty much it.
Well, I see a factory there.
Oh yeah, we just kind of added that as a side thing.
Okay, what about it?
Is if there's more chemical dumping, then the conductivity goes higher and then the water quality goes lower.
Okay. Can you run that model so we can see what the graphs do here?
This is the winter.
Okay, so the weather.
If the winter's longer,
The level of conductivity goes up.
The level, because you're using what?